Hashtag brain-computer interface latest news tutorial script. Imagine controlling your computer with just your thoughts. Sounds like science fiction, right? Well, you're about to discover the latest brain-computer interface breakthroughs that are making this reality today. I'm here to help you navigate your tech journey with confidence, so let's dive into the cutting-edge world of BCIs and what they mean for you. First, let's tackle the big question: what exactly is a brain-computer interface? A BCI is technology that creates a direct communication pathway between your brain and an external device. Think of it as translating your thoughts into digital commands. Unlike traditional interfaces where you use keyboards or touchscreens, BCIs read neural signals directly from your brain, no physical interaction required. Now, here's what most people get wrong about BCIs. They think these devices are purely science fiction, decades away from real-world application. But that's completely outdated thinking. We're seeing tangible, functional BCIs being tested and deployed right now. Companies like Neuralink and Synchron are moving from laboratory concepts to human trials. Per recent medical publications, BCIs are transitioning from theoretical research to practical medical devices that improve quality of life for people with paralysis and neurological conditions. The latest developments are genuinely exciting. Neuralink has made headlines with their N1 implant, which allows users to control cursors and interact with digital interfaces through thought alone. Synchron's stent road device takes a less invasive approach, positioning electrodes inside blood vessels rather than requiring surgical implantation directly into brain tissue. Both approaches are proving successful in human trials, with patients demonstrating remarkable control and communication capabilities. But here's where it gets really interesting for everyday tech users. The advancement in signal processing and artificial intelligence is making BCIs faster, more accurate, and more intuitive than ever before. Machine learning algorithms now decode neural patterns with unprecedented precision. According to recent neuroscience publications, accuracy rates for thought-based cursor control have exceeded 95% in clinical settings. That's incredible progress. Let me break down the key technologies driving this revolution. First, electrode arrays are becoming more sophisticated. Modern arrays contain hundreds of microelectrodes capable of detecting individual neuron activity. The spatial resolution of these devices has improved dramatically, allowing for more granular control and faster response times. When you're giving a command through your thoughts, you want instantaneous feedback, and we're nearly there. Second, signal processing has evolved exponentially. Your brain generates electromagnetic noise constantly. Filtering meaningful neural signals from that noise requires sophisticated algorithms. Current systems use real-time processing that can distinguish between hundreds of distinct thought patterns. The latency, the delay between thinking and action and the device responding, has dropped to under 100 milliseconds. For perspective, that's faster than your eye can blink. If you're finding this valuable, hit that subscribe button. We post tech tutorials daily, and you won't want to miss our deep dives into emerging technologies that are shaping our future. Third, machine learning models are personalizing BCIs for individual users. Your neural signature is unique, like a fingerprint, but for your brain. AI systems now adapt to individual users, learning their specific neural patterns and optimizing control in real time. This personalization makes BCIs more efficient and user-friendly than ever. Let's talk about practical applications beyond medical use. Neuralink's initial focus is helping people with severe paralysis regain communication and control. Patients in trials have successfully controlled robotic arms, typed messages on screens, and interacted with digital environments using only their thoughts. But the implications extend far beyond rehabilitation. Researchers are exploring BCIs for augmented cognition, essentially enhancing human mental capabilities. Imagine accessing information or processing complex calculations at the speed of thought. The accessibility angle is crucial here. Current BCIs still require surgical intervention for the most advanced systems. That's a significant barrier. However, non-invasive alternatives are emerging. These use advanced EEG technology, electrodes placed on your scalp rather than implanted in your brain. While less precise than invasive systems, non-invasive BCIs are improving rapidly. Per recent academic research, non-invasive BCIs now demonstrate sufficient accuracy for basic communication and control tasks. Here's what makes 2026 genuinely different from previous BCI hype cycles. The technology has moved from "it works in the lab" to "it works in real people's homes." That's the pivotal shift. We have documented case studies of BCI users living with implants for extended periods, using them daily, reporting genuine improvements in quality of life. This isn't theoretical anymore, it's functional technology integrated into daily routines. But let's be honest about the challenges. Biocompatibility remains an issue. Implanted electrodes can trigger immune responses over time. Surgical risks, though decreasing, still exist. The cost is prohibitively high. Current systems run into hundreds of thousands of dollars. Regulatory approval is advancing, but standards are still being established. These aren't minor obstacles, but they're actively being solved by the research community. The regulatory landscape is accelerating too. The FDA has granted breakthrough device designations to multiple BCI systems. This expedited approval pathway recognizes both the medical potential and the urgent need for these technologies. Major medical institutions are establishing BCI programs. Universities are training the next generation of BCI engineers and neuroscientists. The infrastructure for mainstream BCI adoption is being built right now. Let's discuss the ethical considerations, because any responsible tech tutorial must address these. Privacy is paramount. Your thoughts are your most intimate information. BCIs will require unprecedented safeguards around neural data. Who owns your brain data? How is it encrypted? Can it be hacked? These questions are being debated by ethicists, technologists, and policymakers simultaneously. The good news? The field is taking these concerns seriously. Security protocols are being designed from inception, not as afterthoughts. Equity is another critical issue. If BCIs become expensive, only wealthy individuals will access them. That perpetuates and amplifies existing healthcare disparities. The responsible tech community is committed to finding solutions, exploring scalable manufacturing, investigating funding models, and pushing for insurance coverage. Here are some pro tips if you're interested in staying ahead of BCI developments. First, follow peer-reviewed publications. Nature Neuroscience, Science, and the Journal of Neural Engineering publish cutting-edge BCI research. These sources provide rigorous, verified information. Second, monitor company announcements from major players like Neuralink, Synchron, and Kernel. Official statements give you direct insight into progress and timelines. Third, explore educational resources from institutions like Stanford's BioX program and MIT Center for Brains, Minds, and Machines. These institutions are pushing BCI boundaries and publishing accessible explanations. The trajectory is clear. BCIs are transitioning from experimental to functional to integrated. We'll likely see expanded accessibility over the next 5 years. Insurance coverage will improve. Costs will decrease. More people will benefit from these life-changing technologies. Non-invasive options will mature. Consumer-grade applications will emerge. What's truly remarkable is that we're living through the birth of a completely new interface paradigm. Just as the graphical user interface revolutionized computing in the 1980s, and touchscreens transformed mobile devices in the 2000s, brain-computer interfaces will redefine how we interact with technology. We're not looking forward to this revolution, we're living in it right now. The implications are staggering. Imagine someone with locked-in syndrome communicating freely with their family. Picture someone recovering mobility after a spinal cord injury. Envision students augmenting their learning through direct brain-computer integration. These aren't hypotheticals, they're happening today. As you explore this emerging technology landscape, remember that you don't need to understand every neural detail to appreciate the significance of these breakthroughs. What matters is recognizing that BCIs represent a fundamental evolution in how humans interact with technology. These are tools designed to restore capability, enhance human potential, and solve previously unsolvable problems. The future of tech isn't just about faster processors or better screens. It's about removing barriers between human intention and digital action. It's about restoring what was lost and enabling what was previously impossible. That's the exciting frontier we're entering. So here's your action item: stay informed. Follow reputable sources. Engage with the science. Understand both the potential and the challenges. The BCI revolution isn't happening to you, it's happening around you, and your awareness and informed perspective matter. As we navigate this tech journey together, remember our motto: navigate your tech journey with confidence. Don't just passively consume technological change, understand it, question it, and be part of shaping it responsibly. Subscribe to Tech Navigator Pro for more deep dives into the technologies defining our future.